In this video, I will introduce context and dependency injection, or CDI. CDI and name lookup in JNDI have a very similar purpose. They separate the use of some object from its configuration and creation. The difference lies in how they work. You've already seen that with JNDI, you look up a context by name. CDI instead uses a technique called dependency injection. Dependency injection is best summed up by what is known by computer scientists as the Hollywood principle. It's based on an old cliche that directors and casting agents in Hollywood would tell an aspiring actor, "Don't call us, we'll call you," rather than telling them directly that their performance was terrible. It does sound nicer than being told, "That was terrible, don't bother us anymore." Though I doubt you'd actually hear it in Hollywood anymore because it is such a cliche. Dependency injection works just like that saying. You don't call the application server to request some object. Instead, it calls your code with the objects that you need. It's like the container says, "Don't call us, we'll call you." And that's why computer scientists jokingly say that dependency injection follows the Hollywood principle. Fortunately for you, the application server isn't just trying to get rid of you, it will actually call your code. Now let's look at how CDI works. With JNDI, or factory methods in a factory design pattern, you create objects when you need them by calling a method that returns the desired object. Instead, dependency injection works automatically. All you do is add an annotation to your fields and properties, and CDI will automatically figure out which class to create, instantiate it, and automatically set the fields. It even works if the fields are private. You can see that these examples here match each other. The code above performs a JNDI lookup and then creates an account DAO object. The dependency injection code does the same thing. It performs a JNDI lookup to set the field named DS, and then it injects into the account field an instance of account DAO that is created using the built-in factory and lifecycle mechanisms of CDI. Let's look at that in a bit more detail. The resource annotation tells CDI to use JNDI lookup to inject a value. So resource means a JNDI lookup. Here are 3 examples using the resource annotation. In the first, a global JNDI lookup is performed. This is equivalent to calling initial context.doLookup. In the second example, a local resource lookup is performed. Now, remember that the Java comp env subcontext is used to store names that are local to your component. And these names are mapped to the global name using a deployment descriptor. So in this case, the resource annotation with name equal to jdbc/db is equivalent to looking up the local name java comp env jdbc/db. In the third example, no name is provided, so a local lookup is performed using the name of the field. In this case, the field is named db, so it will look up db in the local Java component environment. In addition to JNDI lookups using the resource annotation, CDI has a more general inject annotation that allows you to inject instances of any class once you've properly configured it. So to explain what the inject annotation does, I'd like to give you an example. To start, let's assume that we're not using CDI. In this case, we'd first declare a class such as account DAO, and then when we need an instance of that class, we simply use Java's new keyword to create a new instance using the default constructor. Now, if we switch to CDI, that creation becomes automatic. It's managed by the application server. To get CDI to work, you first need to annotate the class with a scope. This scope, requestScoped, tells CDI that it should create an instance of account DAO whenever it receives a page request. Within each page request, CDI will reuse that account DAO object that it created, but it creates new objects for each separate request. Then, to access the object created and managed by CDI, all you need to do is use the inject annotation. To reiterate, you annotate your class with the scope, then CDI will automatically create instances of that class according to the rules of that scope, and set them to wherever you have used the inject annotation. So what are these scopes? Well, requestScoped means that it creates an object for each page request, but that's not the only possibility. Application scoped means that CDI will create just one instance of the class and reuse it everywhere it's needed. If you've heard of the singleton design pattern, then CDI application scoped is basically equivalent to a singleton. Session scoped means that CDI will create an instance per user. So CDI uses the web browser's session to keep track of users. This basically means that your application server will use cookies to remember which instance of your session scoped class to use. Request scoped means that CDI will create an instance per page request. That instance will be reused throughout the handling of a single page request. But when the next page request comes in, then CDI will create a new instance. Finally, dependent is a special scope that creates a new instance every time it is injected. This means that an object exists to serve exactly one object, and it has the same life cycle as the object it's injected into. So you could say that the object becomes dependent on the scope of the class that it's injected into. With practice, you'll gain an intuition about what exactly this means, but one way to look at it is that it is the closest to just using Java's new to directly create a new instance. These aren't the only scopes. There are also view scopes and conversation scopes, as well as the ability to create your own custom scopes. But for now, I'll just consider these four. One of the great things about CDI is that you can have chains of connections or dependencies. You could have one application scope to store global settings, and then you could have a session scoped objects to store user settings, and finally request scoped or page scoped objects to handle the processing of a single page request. Amazingly, these classes can refer to each other even though they might have different scopes, and even, provided some special conditions are met, they can refer to each other in circular dependencies. What makes this possible in dependency injection is something called proxies. Proxies are fake instances that act like a real object. So suppose you were to inject a session scope bean, then CDI will create a proxy and insert that proxy into your object where it's injected. Then when your code calls a method on that proxy, the proxy will intercept the method call, look up the session, and then forward that method call to the real object that should handle the call. So I'd like to consider an example of using CDI. Here's the kind of code that we might use to count the number of visits by a user to a web page. Notice that with each request, I'm storing and retrieving data from the HTTP session object. With CDI, we can replace all of this logic with a session-scoped counter. So we might convert the counting logic into a Java bean, and here's a class that implements a counter. It has a private count, a method to get the current count, and a method to increase the count. The most important thing to note here is that it has a session-scoped annotation. This means that CDI will create a separate instance of this count object for each user. Then here's a servlet that makes use of the session scope bean. Notice that all I need to do is add the inject annotation, and CDI does all the hard work of creating the object and making sure there's a different counter available for each request. What makes this example amazing is that it also shows the cleverness of CDI proxies. You might remember from the servlet lifecycle that only one instance of a servlet gets created to handle all requests. But if there's only one instance of a servlet, then that counter field of my servlet can only refer to one object. This is true, but CDI uses that clever trick of proxies. Yes, counter refers to just one proxy, but that proxy can simultaneously pretend to be many different objects. When you call getCount, that method invocation is intercepted and redirected to the method of the session-scoped count object that corresponds to the current user. When you call the same method in another request, the proxy will intercept it and redirect it again to a different count object corresponding to the user that makes the request. So that's CDI. There's quite a lot to take in, and I believe that the best way to learn is to just play with it. Before finishing, I'd like to offer a whirlwind tour of some advanced CDI features and offer a quick tip. CDI allows you to choose between multiple implementations using alternatives. Now here's an example. Imagine you have an interface for a data access object and that you have two separate underlying implementations that correspond to different underlying databases, either JavaDB or Oracle. You need to choose between those alternatives depending on what database you've deployed it to. Well, with CDI, you can declare those two alternatives using the alternative annotation. Then in your deployment descriptor, you can configure which of those alternatives you'd like to use. So this means that you can choose which implementation to use without having to modify any code. You can make it a simple part of your deployment scripts. You can name those alternatives. Named is a way of telling CDI that your bean can be referred to by a string in Java code. This is generally a bad idea because you can make spelling mistakes when typing names, so I would discourage it. But naming of beans is used by Java server faces. Named is one way you can refer to a CDI bean in other non-Java code like Java server facelets, or perhaps if you need to write your own advanced configuration or templating tools. Another nice feature is that CDI doesn't only work with fields. You can inject in many places. You can have it call your setters automatically. You can have it pass parameters to your constructors. It's up to you which way you want CDI to inject the beans that it manages. They all work the same way. I personally prefer fields because they are so simple, but you might prefer getters or constructors for other reasons. Perhaps you think it looks more beautiful this way. Perhaps you want to do something in the setter or constructor. Or perhaps you just feel it violates the normal rules of Java to let your application server modify the private fields of your classes. Normally, CDI will create instances of your class by calling the class's default constructor. If you annotate a method somewhere in your code using producers, then CDI will use that method to create your object instead of calling the default constructor. If you need to clean up an object that you created using producers, you can also use a disposes method to manually dispose the object. In a Java EE application, there are also some objects that you can inject without needing to declare them. Here are some of them. They're always available, ready for you to use with inject. CDI is a powerful technology and its specification is filled with many features. Some other aspects that I have not talked about are qualifiers, events, interceptors, and decorators. Qualifiers allow you to choose between alternatives and request particular subclasses of an interface. Events are a general purpose event handling technology built into CDI. It allows you to send messages between modules without needing to explicitly declare a function call. Interceptors and decorators allow you to take full advantage of proxies. You can write an interceptor that's kind of a method that overrides every other method of a class. Whenever any method on a proxy is called, it can pass it to an interceptor to do, say, logging or error checking, for example. Decorators are similar, but they allow you to have configurable business logic that you can add or remove during injection in ways that just normally aren't possible using or convenient using subclasses. So, one last warning. Be very careful about using new to construct CDI beans. Dependency injection does not work on any object that you instantiate using new. CDI only works on CDI injected objects. The new keyword is part of ordinary Java code, and the Java virtual machine doesn't give CDI any way to intercept that object creation. So be careful. A simple rule to remember is never use new with an object that's been annotated with a CDI scope. So that's it. There's a lot in the CDI spec, and I encourage you to follow your interests and read more. CDI is very powerful, and it lets you do some amazing things quite easily. The most important things to remember from this video are the 4 scopes: application scoped, session scoped, request scoped, and dependent. You can inject beans with those scopes using just the inject annotation. If you want to inject J&DI resources, then you should use the resource annotation. Just remember to let CDI do all the work. Don't use new to create those objects yourself.